Welcome to Summer Math Mashup, where we will be exploring fun math challenges for families to enjoy together. Summer Math Mashup is a collaborative effort between the Department of Mathematics at Iowa State University and the North Central region of the Governor's STEM Advisory Council.
Hello, welcome. My name is Christine, and I'm so excited to be here today. I am a student at Iowa State University studying mathematics. I love doing math because to me, doing math is like doing a puzzle. I get to put all of these different pieces together, and eventually I get to see this gorgeous picture. It's so rewarding to take all these bits of pieces of information and put them together to solve a problem I've never seen before and didn't understand when I started. This week, we are going to discuss the four-color theorem. Before we talk about the four-color theorem, let's first discuss what a theorem actually is. Theorems are an incredibly important part of mathematics. And a theorem is a statement that has been proven to be true using other true statements. By only using facts that we already know are true, we can write something called a proof to explain how we know that the original statement is true. And once a statement is proven to be true, it's called a theorem. Now, the four-color theorem states that any map can be colored using only four colors. That's it. That's all it's going to take to color in any map. And when we do this, we make sure that any regions that share a common boundary must be different colors. So if we look at this map of the United States, let's look at Iowa here. So this is Iowa, and let's say I color in Iowa blue. That means any states that share a boundary with Iowa are not allowed to be blue. They have to be a different color. So let's say I color in Iowa blue, and then I color in Minnesota red. That means Wisconsin, which shares a border with both Minnesota and Iowa, can't be blue or red. It's got to be a different color. So maybe we'll color in that one green. Okay, so let's make this a little more clear with a map that's colored in. So as you can see, I've colored in Iowa blue, and I've colored in Minnesota red, right? Wisconsin is green. It can't be red or blue because I've already used those, and Wisconsin shares a border with both Iowa and Minnesota. Right? And then Illinois, I've colored in orange because Wisconsin was already green, Iowa's already blue, and needed a different color. So I used orange. Okay? So the idea with the four-color theorem is that you can color in any map completely this way, where there are no states or countries that share a boundary, right, that have the same color. They must be different colors. Now, I should note that a boundary means any length. So if two states touch just at one point, one corner, then they can be the same color. So you can see this happening over here with Arizona, Utah, Colorado, and New Mexico. They all meet at this corner, right? So that means Arizona and Colorado, because they only share that one point, are allowed to be the same color. However, Arizona and New Mexico are not allowed to be the same color because they share a whole border. Okay? Now, the four-color theorem states that this is possible for any map. So that means this should work for the US map. It should work for a map of Africa. It should work for a map that is fictional, drawn out of a story. Any map this should work for. Now, the four-color theorem was proposed in 1852. The man who proposed it didn't have a proof. He just thought this is probably true. He thought it was true. And many, many people tried their best to prove that it was true, and they had a lot of trouble doing it. Many people proposed proofs of this statement, but eventually somebody else found a mistake in their proofs, right? And finally, in 1977, over 100 years later, two people who were working together wrote a proof, and no one has found a mistake in that proof. Think about that. It took mathematicians over 100 years to solve this problem. So when you find a math problem that's hard, think about all the mathematicians who kept on trying to solve the four-color theorem and prove that it was actually a theorem, right, for over 100 years. And even after that proof in 1977 was suggested, people kept on working on it. And in 1996, a shorter proof even was suggested that was a little bit easier to understand. So mathematicians keep on working on problems, even when they're hard, and they work together on problems. Mathematicians collaborate and work together all the time on different problems. And that's how they solve difficult problems. They bounce ideas off of each other and try different things. And when things don't work, they don't get too discouraged. They keep on trying. So I want that to be inspiring for you. When you find a problem that's a little difficult and you don't think you really know how to do it, keep on trying. Embrace what it means to be a mathematician and keep trying to solve the problem. Talk to some friends about how to solve it. Talk to your family members and just keep on working. Now, our challenge for you this week is to color in a map using the statement of the four-color theorem. So all you need to do this is a blank black and white map like this one and 4 colors, right? So I used 4 different colors of colored pencils, but you can use crayons, markers, pens, whatever you have at home. You just need 4 colors, and that's it. Those are all of your rules, right? You only get 4 colors. Any states that have a common border that they share, they cannot be the same color, right? And see if you can make it work. It is a challenge. It's not easy. So don't get too discouraged if it takes you a couple of tries. It's not an easy task, but it can be done. The four-color theorem was proven. It can be done, and this works for any map. So after you do the United States map, try it out with another map, even a map that you can draw. So get your artistic skills out and going. We're going to combine math and art today and try to draw a map and then color it in with only 4 colors. It's a lot of fun to play with this theorem and know in the back of your mind that somebody proved that this is true. So this should always work. It might be hard, but it'll always work. So that is the activity that we have for you this week. We encourage you to explore this activity as a family. Our goal is to empower families and kids in math by making math accessible and engaging. Be sure to check back next week for the next summer math mashup activity. Thank you so much for joining us.
Thank you for joining us this week. We encourage you to explore this activity as a family. Our goal is to empower families and kids in math by making math accessible and engaging. We want to thank all the students in the Department of Mathematics who made this event possible. Learn more about upcoming STEM events and opportunities at www.ncstemhub.iastate.edu.